Hello everyone, myself Dr. Anjana Gogoi, Associate Professor of Statistics, working at Gorgaon College, Assam. Today, I am going to present a lecture on measurement of population growth, and this topic is taken from BSc 6th semester Statistics Major Paper Applied Statistics under Dibrugarh University. Fertility rates are inadequate to give us an idea about the rate of population growth, since they ignore the sex of the newly born children and their mortality. It is obvious that the population increases through female birth. Similarly, if we ignore the mortality of newly born children, we cannot form a correct idea of the rate of growth of population, since a number of female children may die before reaching the reproduction age. There are two reproduction rates which give us an idea about the measures of growth of population. The first one is gross reproduction rate. In order to have a better idea about the rate of population growth, in addition to the age and sex composition of the population, we must take into account the sex of the newborn children, since it is ultimately the female birth who are the potential future mothers and result in an increase in the population. The gross reproduction rate, or GRR, is a step in this direction and is defined as the sum of age-specific fertility rates, which are calculated from female births to the women of age X during the given period in the given region, and then in the usual notation we have GRR is equal to summation over lambda1 to lambda2 FBX divided by FBX into 1000, and which is equal to summation over lambda1 to lambda2 FIX, where FIX can be written as FBX by FBX into 1000, and it is termed as female age SFR, FIX, and more precisely this gives the female gross reproduction rate. So GRR is thus a modified form of total fertility rate and gives the number of females expected to be born to 1000 newly born daughters if none of them is subject to risk of mortality till attaining the age lambda2. That is the upper limit of the reproductive period, and all of them experience throughout the reproductive period the current level of fertility as represented by FIX. So in other words, GRR, that is the gross reproduction rate, exhibits the rate at which mothers should be replaced by daughters and the old generation by the new under the above two assumptions. Suppose that instead of annual data, we are given the figures for different age groups of reproductive period. Let F and BX be the number of female babies born to the woman in the age group X to X plus N. Then in the usual notation, we get GRR is equal to summation over lambda1 to lambda2 N into F and BX divided by F and PX into 1000, and which is equal to summation over lambda1 to lambda2 N F and IX, where F and IX is equal to F and BX divided by F and PX into 1000, and this is the age-specific fertility rate for the age group X to X plus N, and this is based on female birth. So in particular, for the quinquennial data, GRR will be equal to summation over lambda1 to lambda2 5 into F5IX. So computation of GRR requires the availability of the following data. That is the classification of the birth according to the age of the mother at the time of birth and the sex of the newborn babies. But usually such data are not available. So an approximate value of GRR may be obtained under the assumption that the sex ratio at birth remains more or less constant at all the ages of the woman in the reproductive period. Then we have sex ratio is equal to number of female birth divided by number of male birth, which is constant. That is FBX by MBX equal to B for all X. So FBX by FBX plus MBX, which is equal to B by B plus 1 equal to C, another constant, which implies that FBX is equal to C into FBX plus MBX equal to CBX, where BX is equal to FBX plus MBX. This is the total number of births to women of age X during the given period in the given region. Then we have FBX by BX is equal to C for all X, implies that FBX by BX equal to summation over lambda 1 to lambda 2 FBX divided by summation over lambda 1 to lambda 2 BX, which is equal to FB by B. So here FBX is the total number of female birds and B is the total number of birds. So by substituting, we have FBX is nothing but FB by B into BX. So finally, after substitution, we obtain the estimate of GRR as summation over lambda 1 to lambda 2. In the numerator, it is FB by B into BX divided by FNBX into 1000. And after simplification, it is equal to FB by B into TFR. That is number of female bird divided by total number of bird into TFR. Our next reproduction rate is net reproduction rate. The principal limitation of gross reproduction rate is that it completely ignores the current mortality and takes into account only the current fertility. But net reproduction rate is nothing but gross reproduction rate adjusted for this effect of mortality. So, NRR measures the extent to which mothers produce female infants who survive to replace them. It measures the extent to which a generation of girl babies survive to reproduce themselves as they pass through the childbearing age. So let us consider the factor of mortality of mothers in measuring the growth of population. And to formulate this, let us consider a life table for females on the basis of age-specific death rates for females. That is FMX, the age-specific death rate. The value of capital LX is a column from life table denoted by FNLX, gives the mean size of the cohort of FL0 females in the age interval X to X plus N. In the usual notation, FNBX is the number of female birth to the woman in the age group X to X plus N at any period T. Then FNLX by FL0 into FNBX gives the average number of female children that would be born to the cohort FL0 in the age group X to X plus N. Then the quantity Fn pi x, which is equal to FNLX divided by FL0, gives the life table probability of survival of a female to the age interval X to X plus N. And it is called survival rate. It is a life table quantity. So this implies that out of K newly born female babies, K into Fn pi x will enter into the childbearing age interval X to X plus N, and similarly K into Fn pi x plus N into the age group X plus N to X plus twice N, and so on. So hence, instead of multiplying FNBX by FNPX by K alone in GRR, we multiply it by the factor K into Fn pi x, the probability rate for the each of age interval X to X plus N. And finally, a new measure of population growth known as female net reproduction rate is given by K into summation over X N into FNBX by FNPX into Fn pi x, where K is 1000. Now, from practical point of view, this formula can be rewritten as NRR is equal to summation over X into N into NIX into Fn pi x. That is K summation over X into N into female age-specific fertility rate into survival factor. So summation being taken over for all the age-specific reproduction span. Since NRR takes into account the mortality of the newborn female babies, so we get that NRR is less than equal to K summation over X n into fnbx divided by fnpx. This second expression is nothing but the gross reproduction rate, which implies that net reproduction rate is less than equal to gross reproduction rate, because fn pi x, the survival rate, is a probability ratio which is always less than equal to 1. So the sign of equality holding if and only if all the newborn girls survive at least till the end of the reproductive period. Thus, gross reproduction rate provides an upper limit to net reproduction rate, and hence net reproduction rate also ranges from 0 to 5 per annum. So dear students, I conclude today's lecture here. Thank you.